Hello everyone, myself Master Parth Kedia, pursuing BTech in Electronics and Telecommunication Engineering. I am here to present my final project of Emertxe Embedded Systems Online Internship in EV ADAS Dashboard. The Emertxe Embedded System Internship provided a structural learning experience where each concept was introduced gradually before moving to the final project. The journey has started with setting up the STM32 development environment using STM32 CubeIDE and PiximLab. The project objectives are vehicle monitoring, battery monitoring, ADAS alerts, fault detection, and live dashboard visualization. The project results in the real-time vehicle monitoring, live UART communication, Python dashboard integration, ADAS alert working successfully, and fault detection is implemented. In this in this project, the main functional modules are sensor acquisition, EV count controller, ADAS engine, UART communication, and the Python dashboard. In this in this internship journey, we are learned the tools and technology softwares like STM32 Cube IDE, PiximLab, TerraTerm, VSP, and the Python language. Okay. Next, the first implementation was a simple LED blink program to understand GPIO programming and the basic microcontroller operations, in which we are studied that how to set a pin as a GPIO output or input, how to make clock configuration, how to save the IOC file, generate codes, then how to convert it into the bin file and how to upload it into the Pixim lab. Then the next stage focused on the ADC interfacing where analog values from potentiometer were converted into digital values and show it on the virtual term on Pixim Lab using UIT communication, in which we are studied how to pins convert in the GPIO input and how to take RX and TX terms for virtual term, how then same clock configurations and etc. How to make project proper, how to convert it into a binary output, then win file, and how to upload the file and how to make connections on Pixim Lab. Here we can see the output on a Pixim Lab and the virtual term. After gaining the confidence with analog peripherals, we are further studied the LED blink using timer interrupts and PWM. We are introduced to real-time embedded programming. In this, we are used the timer configuration to blink LED. And then finally we are then the internship then moved towards sensor interfacing by implementing a SCSR for ultrasonic cellular data. This was extended to three ultrasonic sensors from front, left, and right obstacle detection. The EV controller module was developed next, where vehicle parameters such as speed, batteries, SOC, motor temperature, drive modes, regenerative braking, and estimated drive range were calculated. Finally, all the modules were integrated to create a complete EV ADAS dashboard. Real-time data generated by STM32 was transmitted using UART and visualized on a Python dashboard. Then the project was success conclusion in the conclusion is the project was successfully implemented and tested. The dashboard accurately displayed vehicle speed, battery status, motor temperature, estimated range, and obstacle distance in real time. This project provided a practical experience in embedded system development, sensor interfacing, UID communication, firmware integration, debugging, and the Python based visualization. the learning experience is like apart from the technical implementation, the internship also included weekly assessments and practical assignment that helped strengthen the understanding of embedded concepts. In overall internship, I learned about embedded C programming, STM32 programming, UART communication, debugging and testing, sensors interfacing, real-time embedded system designs, Python dashboard developments, and etc. This experience significantly improved practical knowledge of embedded systems, problem-solving skills, firmware development, and system integration while proving exposure to world automotive embedded application. Thank you. Thank you for the learning STM32 microcontrollers from scratch and moving from basic hardware control to advanced embedded architectures has been an invaluable milestone. Excited to use what I have learned to solve real world problems in embedded system. Thank you to my mentors and the team at Emertxe. Thank you.